choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
1, 0, all engine running. Liftoff. We have a liftoff.
Houston, Tranquility Base here. The Eagle has landed.
Hello, welcome to Orbit at a Tilt, the space and science show that is fun and easy to understand. I'm your host, Adam Tilted, broadcasting to you live from Space City, Houston, Texas, USA, planet Earth. On this episode, we're going to be talking about NASA's latest engineering amazing achievement, the Parker Solar Probe that was launched a few days ago and will be mankind's first mission to touch the sun. We'll look at the launch, we'll look at the probe, we'll talk about what the mission's all about, what we hope to learn. But first, let's take a look at this week's night sky, because there is a straight up planet party happening. This is the sky, the current night sky from Houston, and you can already see Venus and the moon are going to be peeking out pretty soon. We'll move time ahead just a little bit here. Maybe an hour. Alright, so now, skip ahead. After the sun goes down, so this is at almost 8 o'clock, and it doesn't matter where you are, it will still be 8 o'clock around that time. After the sun goes down, you'll see Venus, and the moon here is just past new. So it is a very tiny waxing crescent. Really good time to look at the moon with a telescope, because you can get a lot of detail. Because there's not so much light washing it out, you can see the detail of the craters a lot better. And because these craters are getting the sunlight at more of an angle, the shadows make it easier to spot some of them. You can also see some of the lips of hills and mountains and crater ledges on the edge of the moon. So if you have a backyard telescope and clear skies, really good time to look at the moon tonight. And it will be close to Venus while you do. By the way, the Perseid meteor shower did peak over the weekend, but this meteor shower lingers for a while because the comet left a really wide debris field, so it's going to take us a while to go through the whole thing. So you can still see some comets if you go out and, I mean, not comets, I'm sorry, you can probably still see some Perseids if you go out, take a look up at the sky. All right, so we've got the back at the night sky here. I'm going to back this up, zoom out a bit, because this is incredible. We've got basically from west to east planets on display. Check that out. Venus, Jupiter, Saturn, and Mars. Mars, again, is it's getting smaller and dimmer every day, but it is still brighter than it has been in a long time and will be in a long time. So good time to check it out. Also, good news, I heard that the global dust storm on Mars was settling down, so you may, if you have a telescope or good binoculars, you may be able to pick out some of the features on Mars since it is close. Let's take a look at the progress of the moon over the week, because this is going to be interesting. It's near Venus tonight, and then tomorrow night it's going to be near the star Spica, which I'll zoom into Spica. Spica is part of the constellation Virgo. And it's a bright star. You should be able to pick it out. It's pretty much in a straight line between Jupiter and Venus. And so tomorrow the moon will be stopping by to say hi to Spica. Then the next day it's over here by Jupiter. And still by Jupiter. And this whole time it's getting fuller. I mean, not fuller. Closer and closer to first quarter. So if we look at the moon here, this is first quarter moon on, no, sorry, this is Friday. Saturday is first quarter moon. So that is first quarter moon. And still a really good time to take a look. On Friday, it will be up near Antares and Scorpius. Still can see Saturn, Mars, all those planets still. And then on the 19th and 20th, it's getting closer to Saturn. As it goes into next week, it's going to get closer to Mars. So that's going to be interesting to see this progress of the moon across the sky from night to night, particularly since we have these bright objects to reference it against. Great. As always, if you have any questions about constellations or sky watching or anything like that, please send me a message or let me know in the comments, and I'll be happy to answer those. Okay, let's take a look at the solar probe, because this is pretty amazing. And NASA put together a little trailer to tell you what the probe is and what it's going to do, and I'm going to just let them tell you. Alright, hopefully I'm not muted anymore. The Parker Solar Probe is a mission to touch the sun. We actually don't know a lot about the sun. It's hard to study. So this mission in particular wants to answer 3 basic questions, and I'll get to those in a minute. But first, here is a photo of the United Launch Alliance Falcon. Jeez, I'm messing this up today. Wow. Sorry. The United Launch Alliance Delta IV Heavy rocket with the fairing and the payload on top. Okay. It launched at 3:30 a.m. I believe it was Monday morning. Might have been Sunday morning. Eastern Daylight Savings Time from Launch Complex 37 at Cape Canaveral Air Force Station. The probe itself, whoops, wrong. The probe itself looks like this. I'm going to come back to this in a second. This is what it looks like inside the fairing at the top of the rocket. The fairing, of course, is there to protect it during launch and orbit insertion, as well as provide aerodynamic advantages for the rocket. This is the probe, and as I mentioned, it has 3 basic questions. The first is, why is the corona, that's the atmosphere of the sun, why is the corona hotter than the surface of the sun? You may not know that, but it is. It's not only a little hotter, it's like 300 times hotter than the surface of the sun. That would be like backing away from a campfire and getting hotter. So that's weird. We don't know what that's about. That's one of the things that this mission is going to help figure out. It has this thermal protection system, of course, because it's going to have to withstand some crazy temperatures. The heat shield on this thing will reach temperatures of about 2,500 degrees Fahrenheit. But because of the amazing engineering that they've done, the inside of the probe will be about room temperature, 86 degrees. Cool, huh? It's about the size of a small car. And you can see some of the scientific instruments here. And I'm going to show you the hold on, sorry. I'm having a little problem manipulating my screens. There we go. Here are the rest of the instruments and antenna there. So the first question is, why is the corona hotter than the surface of the sun? What makes it so hot? The second question is, what causes the solar wind? The solar wind is a constant stream of particles that is flowing from the sun towards the earth. Constant, well, not just towards the earth, but in all directions. Constant flow of particles and radiation and energy, and it goes really fast, like half the speed of light. Why? What causes that? We don't know. So that's question number 2, is what causes the solar wind? Question number 3 is, why does it go so fast? What is driving the solar wind to go half the speed of light? We don't understand. So we're hoping that we can figure out the answers to those 3 questions. This is the orbit that the probe will take from Earth to the sun. So this outer blue ring is the Earth's orbit. This is Venus's orbit and Mercury's orbit. During its whole trip, it will make 6 flybys of Venus, maybe 7, for a gravity assist, and will continuously loop in close to the sun. And its closest approach will bring it within 3.8 million miles of the sun, which that's close. At that point, it will be traveling at 480,000 miles per hour, making it the fastest object created by mankind. And that's crazy fast. So that's why it will need to get the gravity assist from Venus, because in order to go close to the sun and not get sucked into the sun, you got to be going really fast. Okay, this is what the launch profile is going to look like. So you see here at the bottom, the Delta IV Heavy rocket has 2 side strap-on boosters. So once the liftoff is achieved at the proper altitude, the boosters will detach. I don't know if they try to recover these boosters like SpaceX does. I don't think so, but I'm not sure. The central core engine will continue to lift the payload up into out of the atmosphere, at which point the main engine cutoff will occur and the first stage will drop back down to the Earth, leaving the second stage to insert the probe into the proper trajectory to put it into orbit around the sun. So we're going to watch that. Now, incidentally, if you are so inclined, it would be really amazing if you could consider sponsoring the show, if you could be a patron at patreon.com. I have a few patrons that are donating, you know, a little bit a month, and that is really great. That's how I've been able to afford to buy this amazing microphone that has improved the quality of my broadcast. I would really like to boost that regular source of sponsorship so that I can afford to do things like go to one of these launches, because I did sort of have the chance, but I can't afford the travel, and it would be really cool to show you that stuff from the launch, right? Okay, so let's take a look at the launch. As I said, this launch was from Cape Canaveral. So that is that's in Florida. And let me see what we got here, if you can see it. Nope, hold on. Coming at you. Here we go. There we go. All right. I'm just going to let the audio pass through up to a point, and then because it's pretty self-explanatory what's happening at the beginning, but then I will pause it and explain a few things as we go. Okay. Here.
Minus 30.
Status check.
Go Delta.
Go PSP.
Minus 15.
Roll for ignition.
10, 9,
Sensor start.
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
3R68 look good in the full thrust mode. .5 seconds into flight. Chamber pressures continue to look good on all three boosters.
Okay, so let me pop myself up here. At this point, you can see, hold on, I want to pause it here just for a minute. The middle of the three boosters here has gone to half, well, I don't know if it's half, but it's moderate thrust. So the outer boosters are still at full thrust. This one is not at full thrust right now, but it will be. Okay, so keep watching, and you'll see that flame go down. It may have already. It's going to take this probe 3 months to get to the sun. Its first gravity assist will be in October. So by December, it will start transmitting data. Let's listen back in.
1 minute, 19 seconds into flight, max Q, maximum dynamic pressure, and Mach 1, Delta IV is now supersonic.
Okay, that's the point at which max Q, remember what that means? That is when the vehicle has reached the maximum aerodynamic pressure. So from this point on, it will be less pressure. It is going faster than the speed of sound. It is supersonic and is reaching the parts of the atmosphere that are much thinner and offer less resistance. Now, an interesting thing, at 2 minutes into flight, this whole rocket payload is half the mass it was when it was on the launch pad. And all that is fuel that was burned up. Isn't that crazy? Half of its mass. And that's the problem with using rockets, is that more, mass means fuel, and fuel has mass, so then you got to add more fuel for the more mass, and then you have more mass and more fuel, and so it's, yeah, that's rocket science for you. Okay, I'm going to skip ahead here because you just basically see this going off into the distance, and then we'll see the boosters separate. Okay, so boosters have separated. We're now on just the core engine. And it is now at max throttle. And I'm going to skip ahead because this is basically all you see from now on until they do a little animation based on the telemetry.
Ned is deploying. We have pre-start on the RL-10. And we have ignition on the RL-10 engine. Engine chamber pressure looks good. And we have good indication of payload fairing jettison. Now 6 minutes, 20 seconds into flight. And with the boost phase of flight complete, Parker Solar Probe will now continue its journey to the Sun.
Great. So we hope to learn a lot about the Sun, and I've got some images of the Sun that I'd like to show you. If you have eclipse glasses, if you got glasses for the eclipse and you still have them, use them. Look at the Sun. You'll see something like this. Now this is extra special because someone was able to catch the International Space Station transiting the Sun, but this is a sunspot, and you can see those if the sun is out. Now, of course, don't look at the Sun without eclipse glasses, but if you have them, go use them and see what the Sun looks like. This is what we know about the Sun, or we think we know about the Sun, basic structure here. We're not really concerned with most of this inner structure with this mission. It's this corona. That's the part that we see revealed during a solar eclipse. And also these things called these prominences. The Sun has a very complicated magnetic field because of all of these radioactive charged particles that are moving all around, bouncing off of each other very fast. It creates this weird tangle of magnetic field lines, and they break apart and reconnect and throw off stuff into space, and we don't know why. So this is a big prominence on the Sun, and it's a filament actually that's just kind of drifting in the atmosphere of the Sun. Strange. And this is a view, I believe we're getting more into X-ray views here and other wavelengths of light. This is a series of images of comet Lovejoy something, I forget which one. It's Sun Grazer comet. Now, it did not make it all the way around the Sun, but it also did not crash into the Sun. It just vaporized. It got too close and this was one of those comets that came out of nowhere. It was probably its first trip from the Oort cloud into the solar system, and it didn't make it. The solar wind is what causes the aurora on Earth, because those charged particles, when they get to our magnetic field, the magnetic field directs them to the poles where they interact with gases in the atmosphere. So those gases get charged by the charged particles, and they glow, causing these aurora. And Earth is not the only planet with aurora. Saturn has aurora. Jupiter has aurora. My face is in the way of one of the aurora. Let me move it. So that is what we hope to learn from this mission. as I said, we'll start getting data in December, and it's usually a couple months after that when things are released to the public. I mean, the data is public, but I won't know what it means. I'll need them to explain it to me. Okay, so I hope you enjoyed today's show and learned a little bit about the Parker Solar Probe, which, by the way, is the only NASA mission to be named after someone who is still alive. Eugene Parker, who was the first one to theorize about solar wind. So, and don't forget to enjoy the Planet Party this week. I will see you later in the week. We've got a special episode of Getting to Know You coming up tomorrow. Ooh, tomorrow. I'll let you know more about that in the morning. And until I see you again, don't forget to look up. Bye.